Hey everybody, this is Larry. This is day 25 of the 30-day Leetcode challenge. Let's jump right to it to week 4 jump game. Let's do it. Hit the like button, hit the subscribe button, and remember, I'm solving this live, so you know, do what you need to do. Jump game. Given an array of non-negative numbers or non-negative integers, you're initially positioned at the first index of the array. Each element of the array represents your maximum jump length in that position. Determine if you're able to reach the last index. Okay. So this seems pretty straightforward in the sense that you could maybe calculate it as it's a sort of a connected component. Um, and at first it's going to be n squared because that's the number of kind of edges that you have in the graph that you're going to build. Um, and you can actually do a couple of things knowing that it is connected components. There's DFS, there's breadth first search, BFS, there's union find, and then there's also not strictly connected components per se, but you can do reachability with a 0, 1 BFS, which is, well, BFS, but with a special way to do it. Yeah, I mean, I'm actually way from, so and all of that will be linear in terms of, well, linear in terms of technically the graph size. The graph size is going to be V plus Y, V for the number of vertex, Y is for number of edges. And the number of edges is not, it could be V or it could be V squared in this case. So it's not, so yeah. Let me see if I could think about anything more clever. So that's kind of how I would think about it. I think for learning purposes, I'm going to try 0, 1 BFS. And it would take me it would take me almost no time to write. And it's something that I'm going to learn about a little bit. Yeah, do I even need a, I guess it doesn't really even have to be 0, 1 BFS. It's just a regular BFS because there's no weight because it's connectability. And I think I just wanted to point it out just because I think I wanted to learn and practice it because I've seen it recently. But that said, I don't even know. And I think the other thing I'm trying to think a little bit is whether we could even be a little bit lazier in terms of like looking at this. If all the numbers are positive, then we can always, I want to say that the only, so you have to like handle 0 differently maybe, but so then you can maybe do some greedy algorithm that way. And because actually in this case, well, I think it makes no sense to jump to your left. So you're always going to jump to your right. So I think actually a easier algorithm, I mean, you could definitely do what I mentioned with the DFS and the BFS, 0, 1 BFS, union find, and you could kind of calculate the complexity to that. But there's actually, I think, an O of N algorithm where for each, it's kind of like, it's almost like dynamic programming in a way, in that for each index, we calculate the farthest that you can jump at that moment in time. And if that farthest point goes extend to the last index, then you can get there, right? I think that's it. So I think I'm going to try to do that. So I would say it's kind of interesting because if you think about the other algorithms we talk about, it's going to be n squared or v squared because that's the degenerate number of edges. But in this case, it's always going to be O of n, so it's even better. So it's linear, and I'm going to try. I'm going to code this up first, and then we'll talk about this afterwards. Cool. Okay. So let's just say farthest is equal to 0, and then for I'm just going to use the enumerate enumerate nums, and then the farthest is equal to max of the index plus num, right? Because from 0 you could jump 3, so it goes to 3, and then so forth. Yeah. And I think the only caveat we have to do is, or for check for, is if farthest is less than index, then we return false. Otherwise, we just return true. Because that means that the current index is no longer farther than we can jump. Okay, so let's run the code. Let's put in more examples. Okay. Did I have a typo? It's possible. Int object is not on line 9. Oh, whoops. That makes sense. Okay. And then I think we can just try the other cases, probably like, let's just say 5 and then a lot of zeros and then jumping to the end. I guess do I have to go to the last index? Okay. So we might have to check a little bit on getting to the last index but 0. So, because I might handle that incorrectly. Yeah, let's run this. Okay. Oh, because it gets to the last index. So then the index, okay, maybe that's right. I'm just a little bit worried about off by 1 as usual, because in this case, okay, I think that's what I'm going to test, if it's correct. Just testing a few things that may be weird, but okay, let's submit, and cool. So accepted. So you can do this in about clearly like 5 lines of code or 6 lines of code. Very simple problem once you kind of get down to it. So first of all, this is greedy. This is O of n time, O of 1 space, but it's very tricky in that, at least for me, greedy problems requires proving something that that the subproblems of the greedy solutions are all optimal. And in this case, it makes intuitive sense, which is not good enough for greedy. And I don't really have a great proof about it per se, or like a great strict mathematical proof. I think it makes sense that given an index, if you can get there from any other point, and from that you could work backwards of, well, you could get it from any other point if the furthest you can go from any of those points gets there and so forth. So you're almost kind of, I don't know. I might not have a great explanation for this problem, but that's how I solved it. It's O of n. Yeah, I mean, greedy problems are always going to be tough for interviews, so definitely, I don't know, have a better justification than I did. But overall, definitely have seen greedy problems. I don't know about this particular one, and it is an interesting one. I think anything more complicated, I would try to do something like maybe a depth first search or breadth first search, or depending on how complex it is, maybe dynamic programming or something like that, depending on the problem. But yeah, overall, reachability problem, this is interesting. I think I have some experience of similar problems. That's why I'm able to get the answer, the greedy answer. I think if you have done the shortest path, I think that would have been okay too. But yeah, that's all I have for this problem. Thank you, and hit the like button, hit the subscribe button, and yeah, I'll see y'all tomorrow. Bye bye.